Ever since they learned to forge, humans have loved metals. And not just because they're shiny. Bronze took them out of the Stone Age, and with the Iron Age came steel. Stronger, harder, and more durable than bronze, it laid the groundwork for the construction of everything from trains to skyscrapers. But making steel releases harmful greenhouse gases, and now accounts for a whopping 8% of global carbon emissions, more than aviation and shipping combined. And with demand set to grow by 50% by 2050, humanity needs a better, more environmentally friendly approach, and fast. Welcome to the age of green steel. The modern world is quite literally built with steel. Humans use almost 2 billion tons of the stuff a year, and half of that is used in construction, building up an area the size of Manhattan every 3 days. In fact, humans love steel so much that 92% of mined metals are used to produce it. But how exactly is steel made, and why is it so polluting? Well, modern industrial steelmaking was first pioneered by Englishman Henry Bessemer in 1856. His methods paved the way for the eventual construction of impressive structures like the Empire State Building and the Burj Khalifa. But before you can make all that lovely steel, you need to dig up the key ingredients, iron-rich rocks called ores, and a source of carbon like coal. These allow us to begin stage 1, separating iron from its ore. First, you mix the iron ore with high-carbon coal and limestone in a blast furnace and simmer the mixture at a toasty 1,600 degrees Celsius. This causes the carbon in the coal to react with the ore to produce molten iron and carbon dioxide gas. Then comes stage 2, strengthening the iron to make steel. You pour the molten metal into a second furnace called a basic oxygen furnace and inject it with high-pressure oxygen. The oxygen reacts with the carbon remaining in the hot metal, producing even more carbon dioxide gas. This cuts down the carbon in the iron to ideal levels for strength and durability. The result? You've made steel. And, unfortunately, a lot of carbon dioxide. In fact, for every ton of steel produced, almost 2 tons of CO2 are released. And the steel industry emits roughly the same amount of CO2 as the entire European Union. Steel isn't as shiny and clean as it seems. So how can humans get to the new age of green steel? Well, there are 6 solutions to explore. One option is steel recycling. Renewable sources like wind and solar can be used to power an electric arc furnace to recycle steel. This can melt existing scrap steel that would otherwise be wasted and recycle it to make new steel, reducing CO2 emissions by up to 85% compared to making it from scratch. But while recycling is a start, steel is already the most recycled material on Earth, and recycling alone can't meet humanity's insatiable appetite for the shiny stuff. So the next solution is to try and catch all the carbon from traditional steelmaking, store it in underground reservoirs, and prevent it from polluting the air. This is called carbon capture. And in theory, it can significantly reduce the CO2 released by steelmaking. But carbon capture can't catch all the CO2 and risks leaking the captured gas back into the environment. And because it requires a lot of energy, and for the time being comes with a pretty hefty price tag, it's not going to bring about the age of green steel on its own. A better approach is to replace the dirtiest and most polluting part of steelmaking entirely: coal. And this is something that the next solutions can do. The first way is with biocarbon. Many companies are experimenting with replacing the coal used to react with iron ore in the blast furnace with a source of carbon derived from sustainable biomass like wood or other plant matter. Biomass can also replace the coal used to heat the furnaces in both stages of steelmaking. And since trees are planted specifically for this purpose, this makes most of the emissions from steelmaking carbon neutral, which sounds great. But because there are limits to how much biocarbon can be produced sustainably, it's unlikely to play a large role in decarbonizing steel. A much more promising method is by using a process called direct reduced iron. This typically replaces coal in the blast furnace with fossil gas to separate iron from its ore at much lower temperatures and with much lower emissions. It's so effective that it's already being rapidly scaled up around the world. The only problem is that while using gas can reduce the emissions of the first stage of steelmaking, it can't eliminate them from the process completely. Fortunately, adding the next ingredient to iron ore can get pretty close: green hydrogen. This is made from using renewable energy from sources like wind and solar to split the hydrogen from water. And like fossil gas, it can be used to separate iron from its ore, but unlike gas, green hydrogen doesn't produce any CO2 at all and essentially eliminates the carbon emissions from the first stage of steelmaking. In stage 2 of the process, the iron can be turned into steel in an electric arc furnace. There still needs to be some carbon added, but this can be from recycled materials like scrap steel, bio-waste, or even plastic and old tires. And all this can be powered by green electricity. So, together, these methods can reduce the carbon emissions of steelmaking by over 95%. Sweden is already starting to produce green steel this way, and many other countries are trialing the technology too. But to make hydrogen steel a global reality, both hydrogen production and renewable energy must be significantly ramped up, which is no mean feat. But what if there was a way of bypassing the need to make hydrogen entirely? Well, there is. Molten oxide electrolysis. This method is being trialed in the USA and Brazil and uses renewable electricity directly to separate iron from its ore in a process called electrolysis, producing only oxygen as a byproduct. Like hydrogen, this virtually eliminates direct CO2 emissions from the process, but could do so in a much more energy-efficient way, bypassing the expensive and energy-intensive process of producing hydrogen. And while this method has yet to be proven at scale and currently uses a lot of heat and electricity, other low-temperature alternatives are also being explored. Together, they represent an exciting glimpse of the future. So is humanity on the cusp of a shiny new age? Well, with the right investment in research and development, the continued expansion of renewable electricity production, and a supportive policy environment, humanity can finally get to their destination, the age of green steel. Please spread the word about climate change solutions by sharing this video and like and subscribe if you would like to see more. Thank you.